Hello, once again, everybody, and welcome to Learn Math with me, Brian Sapinski, and
Hi.
and yeah, and Brianna too, of course. And okay, before we start this video real fast, she could not help but show you her new favorite purchase. her
It
favorite.
had to. It's gonna stay here the rest of the video, and yeah, stay here. I like wall picks.
You
Okay.
you make it sound like it's gonna move on you. We're gonna focus on multiplications of multi-digit by single-digit numbers. And we're going to look at the general strategy that is used to try to perform that multiplication, and also a couple of important side tips and tactics that we want to address along the way, some of which revolve around things that we talked about in last week's video. You'll see what I mean as we go along. So first, let's cover the main base. All right, let's say we're doing multiplication of the following numbers, just to introduce. All right, like I said, the numbers, as you can see, are going to start to get bigger. We have 218 times 7. The first thing we want to do is to try to use estimation, whether it be to the nearest 10, to the nearest 100, to the nearest 1,000, whatever the most appropriate place value is, to try to get some approximation to let us know that we're on the right path. Now, if we can help it, depending on the number, we'll see as we go along, depending on the number, if we can help it, let's try to round to the nearest whatever the highest place value happens to be. So for this number, we have 218. Being that that number goes into the hundreds, let's round to the nearest hundred, and so we can get it down to a single digit followed by all zeros. That would round then,
200.
okay, that would round to 200, which now when we multiply that by 7, we can focus on single digit times single digit, as we did last week, carry the zeros over, and that gives us what approximation?
1400.
Okay, so we know the answer is going to be somewhere in the range around 1400. All right, knowing that now, let's do the actual multiplication for real. We start, as we go, normal order, right to left, we do this multiplication. So first, multiplying 8 times 7, that gives us,
56.
okay, but you only write down what digit?
The 6 instead of 1 place.
Okay, 6 goes into one place, and the 5 from the 56 goes.
Carries over.
It carries over above. You place it above the next place value in the number, which in this case will be above the 1. So what happens with that 5? Well, first, you got to multiply what's actually there first, which is the 1 times 7, which would give you
7, but adding the 5, that would be 12.
Right, okay. And once again, in this case, again, we've got another double-digit answer. So which number comes down? Which digit?
The 1.
No, wait. Which digit? No, wait. Which digit comes down?
Oh, is it? Oof,
Relax. The 2 comes down, and the 1 goes above the next digit. Okay. So then, again, we save that 1 for after we do the next multiplication. So 2 times 7, which you already know is 14, plus the 1 that carried over.
15.
And we now have our final product, which came out to
1,526.
Yes, exactly. Okay, like I said, don't necessarily worry if the actual number is slightly more distant from your estimated answer than you think it is. It should be, again, we're looking for roughly around the area. You'll know if it's really off. So let's take another example, for instance. Okay, 4,963 times 3. Now that one goes into the thousands, so if we round that off to the nearest thousand, that would be what?
5,000.
That'll be 5,000 times the 3, so that gives us about 15,000. Now again, we do the multiplication for real. Okay, so we have 3 times 3. Okay, you have the 9 there, so there's no carry in that one because that's just a single digit, no grouping necessary. Okay, she's done 6 times 3 for the 18. That one does have a grouping. 8 goes down, 1 goes up to the hundreds place. Now she's doing 9 times 3 plus the 1, and she gets 28. 8 comes down, 2 goes up, and finally 4 times the 3 for 12 plus the 2, she gets 14. Final number, Miss Wavy, final number?
14,000. 15,889.
Okay, that fits in the theme again, the
Here's the
15,000.
numbers.
So you can see it, so you can see again your approximation. Now, usually, if you could round to the highest possible place value given to you in the multi-digit number, yeah, go ahead and do it. Sometimes, though, it might not always be the best idea in the world. For instance, take this multiplication, 2,659 times 2. Now, if you were to round that to the nearest thousand, since that's how far it goes, that would take you up to 3,000. Now, the thing is, though, when you do the real multiplication on this one, okay, 3,000 times 2 would give you
3,000 times 2 would be 6,000.
6,000, okay. But the real answer, as you're going to see it here, is quite a bit off from that. It actually comes out to 5,318. So it seems a little distant, and that could sometimes perhaps lead you to thinking, so wait, did I estimate this wrong, or did I do the real math wrong, or whatever the case is?
Yeah,
So,
that's what I was confused about.
right,
But then
exactly.
my teacher told me when people were starting to get a little bit upset that they were getting the estimations wrong, she said that the estimations don't really matter as long as you got the real answer right.
It doesn't matter what your estimate is. True, I know. You're trying, the point is you're trying to use the estimation to build just a little extra confidence level to make sure that you know that the calculations you're doing are about what they're supposed to be. Now, obviously, you want them exactly what they're supposed to be, but you get my point. All right. Now, if you want to, just as a little help of avoidance or whatever, if you're worried that going to the furthest place value is going to mess you up a little bit, try instead to go one place before. So, like for instance, with 2659, let's say you round to the nearest 100 instead. That would give you 2,700 to multiply by 2, which gives you about 5,400, and 5,400 appears much closer to what the real product is supposed to be. It may slightly complicate things, but again, the whole point is you're trying, again, it's building the confidence. So you play it as you see fit, okay? Now, there's another strategy that with some numbers, depending on how they read, there's sometimes some numbers that you could employ a different multiplication strategy to get your exact answer. And this will harken back to what we talked about last week when we were discussing the distributive property. Here's a little extra tactic you sometimes use. Like, let's take, for instance, the multiplication 608 times 4. Now, you can see that rounded off, 608 is very close to
600.
Okay, so given that, what you could potentially do is take the 600 that 600 portion and split it off, and then the extra 8 becomes a plus 8, and now looking at that, you have a distributive sentence. 4 times the sentence 600 plus 8. You do each single digit multiplication in and of itself. You add those results together like we did in previous distribution and get
2,432.
Okay, now same idea. What if instead of having the number be a little higher than your rounding, what if it was a little lower? Take the multiplication 1,996 times 8. Now, 1996 rounded to the nearest thousand would be
2,000.
Okay, now since that's a little higher, if you try to make a distribution sentence out of this, you would have the 2,000, but since that's higher than the actual number, you would need a subtraction following it. But again, the distribution still holds. 8 gets multiplied to both of those things. So 2,000 times 8.
2,000 times 8. 6. Wait, nope.
Right, yeah.
16,000.
16,000. And 4 times the 8 would be
4 times 8 is 32.
32. Now, since that was a minus because the real number was lower than our estimate, we would have to do 16,000 minus 32 to get the real answer here in this case. Go ahead.
So 15,968.
Exactly. So sometimes when you got those numbers that are really close to a multiple of 100 or 1,000, especially if it's the furthest digit along in the multi-digit number, employ distributive as well and take that tactic to it. It could sometimes help you get your exact answer as well. All right, so with that in mind, okay, we're going to do a little something different here in this video, all right, because we want to get you, our viewers, involved in this a little bit too and give you some practice in it, all right? Take a look now on the screen at these three multiplications. Now, obviously, your object, we want you to multiply and see what products you get using the grouping that was described here. And now, before you do that, do as we did to see that you know your answer is going to be as appropriate as possible. Try estimating each of the multi-digit numbers that you see here on the screen and see approximately what product you're supposed to get. And then do the actual multiplication. And along the way, if in at least one of these problems, you can employ a distributive tactic like the ones we just demonstrated as well. So if you want to try to solve that one by that method, you can do so as well. Pause the video right now, take a couple of minutes, see what answers you get, then we'll come back to you.
No rush.
When you hit the play, of course. Okay, feel confident in your answers? Let's find out. First, let's start with the estimations. If you took each of the multi-digit numbers in these problems and rounded them to their highest place value, and then performed the single-digit multiplications, your estimated products would have been, and as a footnote, if you felt that the last one was a little too far off and you decided to round to the hundreds instead, that would be acceptable also. So now, if you then did the grouping multiplications to all of these, you would see that the actual products would give you the real answers of these. And did you see that one of these had a distributive option if you chose to go that route? The first problem could have seen the 78 been translated into
80 minus 2.
Which if you then did the distributions, the 80 times 6 would give you the 480 that matches your estimate, followed by 2 times 6 for 12, the subtraction of which would give you the same 468 that you should have gotten. So I hope that now, after all this, you feel more confident in your own multiplication abilities with multi-digit times single-digit. And of course, the numbers are just going to grow from here, but that's another week for another time and another video and another whatever else I'm going to say. For right now, let's just say goodbye. But before we do that, please, if you enjoyed this video, put a like on it. Please share it with your friends, especially anybody that has fifth graders that could use some math help. And be sure to subscribe to this channel so you can see next week's video and the weeks after that and everything else to come around here. And if you want more problems to practice, please shoot me an email, brian.sapinski@gmail.com. I'm ready to help you with whatever it is that you feel you may need. So until next week or whenever we next speak, she's Brianna. I'm Brian Sapinski, and she's doing this again. Why are you still doing this? See ya.